Welcome to BDB Platform Model Observability Demo. In this video, we will explore the process of attaining model observability and monitoring within the BDB platform. Model observability refers to the ability to understand and monitor the behavior and performance of a machine learning model during its deployment. It involves tracking and analyzing various aspects of the model's functioning to ensure that it meets the desired criteria and continues to perform well over time. Key aspects of model observability include monitoring inputs and outputs, performance metrics, data drift detection, model health checks, error analysis, logging and auditing. Effective model observability is crucial for maintaining the reliability and trustworthiness of machine learning systems, especially in real-world, dynamic environments where data distributions and model requirements can change over time. We have already developed a machine learning model in our DS Lab module. In this module, we added datasets and performed transformations using data preparation. Subsequently, we trained the model, evaluated its accuracy, and saved it for deployment. After preparing and checking the model, we saved it and then registered the machine learning model for operational use in the data pipeline for performing inference. Now, let's delve into the data pipeline. In this data pipeline, we are utilizing our synthetic data generator component to generate laboratory-generated data for the model input. Now activate the pipeline. After data enrichment and transformation, the data undergoes inference. Subsequently, the Kafka event that stores the model output is segregated into two flows. In the below flow, the model output undergoes transformation before being written into the database. The above flow is employed for monitoring the statistics of model output columns. This component calculates the statistics for each column of the data, and the data is received in batches. For each batch of data, it calculates statistics, assigns a unique timestamp and UUID, and then writes the results to the database. If there is any deviation in the data beyond the set threshold, the retrain data filter component captures this data and writes the output into the database. This indicates that our existing model is no longer suitable for inference on the current data and needs to undergo retraining. Now, let's explore the report for model observability. In the initial tab, namely Model Monitoring Analysis, we can visualize various metrics calculated before model training. These include the predictive power score, feature label correlation, data leakage, conflicting labels, and dataset size comparison. PPS score or predictive power score. This metric assesses the predictive power of features in relation to the target variable. Understanding feature importance guides feature selection or engineering, allowing a focus on the most relevant variables. Feature label correlation change. Consistent performance between training and test sets is essential for model generalization. Significant changes in feature label correlation may indicate issues like overfitting or dataset shift, affecting the model's ability to perform well on new, unseen data. Data leakage. Data leakage occurs when information from the test dataset is somehow used in the model training process. This can lead to overly optimistic performance estimates because the model has effectively seen the test data during training. Conflicting label. Labels may be inconsistent or conflicting. Ensuring label integrity is important for training a model that accurately represents underlying patterns. Conflicting labels can lead to confusion and misinterpretation of the target variable. Dataset size comparison. Evaluating the proportion of rows between training and test datasets is essential for ensuring balanced model training, preventing issues like overfitting and promoting robust generalization. On the second tab, Column Stats Monitoring, we analyze various statistics of the data, including mean, median, minimum, maximum, standard deviation, and unique number values concerning the timestamp. In the data pipeline, we observed a deviation in the data or data drift. This is evident in the key performance indicators, KPIs, that reflect the deviation. Now, it is apparent that it's time to initiate the retraining of our model. Thank you for watching.